Hey everybody, this is Matt with mathsmath.com. Thanks for joining us here today as we talk about how to find volume of prisms and cylinders. We are in the Math Common Core Standard of Geometry, and we're going to be figuring out how to describe volume of these two particular shapes of both prisms and cylinders together. Alright, can you find the volume of a cylinder or a prism? That's going to be our question, and that's what we're going to be able to answer today, okay? Alright, well here is value, 100% orange juice. What we're going to talk about today is figuring out how can you find out exactly how much is inside this can. We can measure it, take all the measurements and figure out what the volume is of this can. Let's do it, alright? Alright, so volume, simply put, is the space inside of an object. Well, when we look at cylinders, they can be found, the volume can be found of a cylinder much like that of a prism. So let's review what that is, volume of a prism. Well, the volume of a prism simply is taking A, which is the area of the base, and multiplying it by the height. You can imagine that if you had the area, this shape right here, and you stacked it up h times, that would fill up this prism, wouldn't it? No matter what the shape of the prism's base is, this will be the formula that we're going to use, okay? So with cylinders, the same thing goes. Just because the base is a circle doesn't mean the formula changes. The volume is still the V, A is still the area of the base, and H is the distance between the two bases. Okay? So A, the area of the base, is pi r squared. Remember, pi are not round. Pi r squared. So the area of this is taking pi times r squared, and that gives you the area of this guy. And then you're stacking it up. Imagine you're taking it and stacking it up h times. So that's the distance between the two bases. Pi r squared times h is the volume of a cylinder. Pretty simple, huh? Well, let's do that. Let's compare these cylinders. I want you to find the volume of this one and the volume of this guy. Remember, it's pi r squared. So pi times r squared, r is 2, and then multiply it by 9. In most of these examples, you are not going to need to multiply pi out. If you just leave your answer with some number times pi, you'll be good to go, okay? Same thing with this one. 3 inches, so pi r squared, pi times r squared, 3 squared, which is 9. So 9 pi times 4, so that's 36 pi. Bam, so what'd you get? Which one's bigger? Any idea? Kind of a trick question, isn't it? Because when you solve for the volume, you get 36 pi inches cubed on both of them. Like I said before, you do not have to multiply 3.14 out. From here on out, usually if you just write pi on the outside, you're good to go. So 36 times pi, it saves you from having to take a step there and multiplying 3.14 out. Alright, would you find the volume now with the diameter? Wait a minute. It's really not that much difference, is it? You've got 12 as the diameter. Well, cut that in half, and that gives you 6. All right, so from here to here is 6 centimeters. So pi r squared, so pi times 6 squared times 5 gives me 36 times 5, which would be 180 pi centimeters cubed. Remember, it's volume, so that it's cubed. Okay, the units are going to be always cubed. VA, pi r squared, got to divide it out, and you get 180 pi times cubic centimeters. If you see a cc, that means cubic centimeters, okay? Why don't you do these two on your own? Find the volume of the left cylinder and find the volume on the right. On the right problem, you are working backwards, so you're going to give me the height of this. Notice that this is the diameter and not the radius, okay? All right, if you are having trouble with this guy on the right, set it up so V equals AH, where V is 84, and then work backwards. It's a one-step equation that you go backwards. All right, here are your answers. Ready for them? Here you go. Number 4, definitely it's around 3 inches, rounded up there. Now think about these two cylinders. The larger one has double the radius compared to the smallest cylinder, and they both have the same height, okay? So if this guy has a radius of 2, let's assume that this radius is double, so it's 4, okay? Now, what's the ratio of the two different volumes? Well, first you might have to actually find the volume of the smaller one and then the volume of the bigger one. And then let's figure out the ratio there. Well, the one on the left is pi r squared. So 2 squared, which is 4, times 1. So this volume is 4 pi. Why don't you find the volume of this guy? Again, our radius is 4, so it's pi r squared, so 4 squared, which is 16 times 1. So here, the volume is 16 pi. Well, if I set these guys up together, what is going to be my ratio? 4 pi to 16 pi. Well, if you notice, I've got a pi over there and a pi over there, pi everywhere, everywhere a pi. Cross them out. Bam, bam. Now, how can we simplify 4 and 16? 1 to 4. All right, so if you double the radius, what do you do to the volume? You multiply it by 4. Okay, multiply it by 4. That just goes for any volume there. If you double the radius of cylinders, you're going to quadruple the volume. All right, see if you can do this one on your own. A can of orange juice from Value Orange Juice calls for 1 can of the concentrate plus 3 cans of water, so 4 cans total. How much does the total mix and the water come to when you add the concentrate together with the water? 6.5 in diameter, it's 12 centimeters tall. How much orange juice are you going to make? All right, how you doing? A quick note here about your environment and your culture that you live in with all of these units is 1 cubic centimeter, or a cc, if you've ever heard doctors talk about that, 1 cubic centimeter, cc, is also known as 1 milliliter. So that's how they translate to one another. 1 cubic centimeter is also known as 1 milliliter, okay? So if you think about it, how many milliliters or liters does this can of orange juice make? Alright, so a cylinder has a surface area of 1470 square meters and a radius of 9 meters. What is the volume of the cylinder, the nearest whole number? Now you got to work backwards. You're starting with the surface area, so you got to work backwards to find the height of the object. If you remember from one of the other lessons we've looked at with surface area of cylinders, you're going to take surface area. You've got 2 bases. You multiply it by the circumference. I'll give you a hint here. You've got 1470. This is your surface area times 2 of those bases plus circumference, the perimeter, times the height. So you know that it's 1470. You know what the area is because area of a circle, remember, pi r not round, pi r squared. So pi r squared, plug in r for 9. Bam, you've got circumference again. You know what circumference is. 2 pi r. So you can plug in 9 for r there, and then work backwards to solve for h. And then, now that you have h, you can find the volume because you have the radius and the height. All right, here's your hints. Look at the OJ there. Notice you're making about 1.6 liters. If you think about it, how do you turn milliliters to liters? Divided by 1,000. There's 1,000 milliliters in a liter. Take that out, you get 1.6 liters of orange juice. Good. All right. Well, can you find the volume of a cylinder in a prism? I bet you can. Not much different than finding with a cylinder or with a prism, huh? Well, that's pretty much it as we talked about the volume of prisms and cylinders. I hope you guys enjoy orange juice as much as I do. This was Matt with mathsmath.com. Thanks for joining us. And check us out on Facebook at Solving Maths Problems and Twitter, Maths Math, and enjoy math.